Computation, and I work as a researcher within Zaha Hadid Architects. Funny thing is, we are a very small, like it's a sub-project amongst a large series of projects that designers tend to work. So for us, complexity is largely represented by like multiplicity. And I'll walk through like the various kinds of multiplicity that we encounter during our work. One, we are a growing office, so like we get more and more designers signing up, let's say. So the first problem, or let's say the first aspect of complexity, is the number of people working on a project. And their design backgrounds and their core skills, and all of these add up to various fragments of computation-related issues. For instance, interactivity of tools as a group. This was just a small test tool to quickly come up with configurations for before you start out designing master plans, just to get an idea of massing and like distance between buildings, gaps in the periphery and things like that. But one reason is like this tool never got used is because it was too slow, and the designers would never agree to use something like that because they're somewhat used to things working quickly, interactively, and they're kind of intuitive sculptors. So as such, interactivity and like so multiplicity of designers is an issue within our general area of research or of design and computation, how to make things interactive for many people to use. And it's like, so in a way it has to be dumb enough, but not, but still useful enough. So the next issue of multiplicity is that of scale. In digital design, like you might come up with patterns and things. Personally, I feel that until you assign a scale to something and then look at the performance of that particular object at that scale, it is pretty much scaleless. So for instance, in this case, it's a building in India. Like we came up with a tool to frit glass panels on the facade. So you quickly paint these kind of these zones, and it makes the fritting pattern for you, makes out circles and sends it out to the printer. The same tool we also use to make paintings. In this case, whereas in the fritting pattern on the facade, it was a regular grid. In this case, we had explored grid sizes, varying in like Fibonacci series or whatever else, and played with. We had a lot more freedom, let's say. So again, issue of scale is one aspect of complexity within our work. So we decide on a scale and we execute details at that specific scale. This is another similar intuitive thing that the artist just paints and it makes bigger holes, smaller holes, extrudes and not extrudes. So essentially it is enabling the designer to be intuitive. The next aspect of complexity, let's say, is again coming from the various designers. The number of designers is they all use different platforms to design. In the end of the day, when we have to construct, we have to transfer geometry from one platform to another. And this is a project in Michigan where it was as a competition won as a Maya model, and for the purpose of construction, we had to now transfer it into some other, like a platform like CATIA, let's say, which enables more easy fabrication. So in this case, like the main issues were making sure that we are not transferring dumb geometry. We are keeping some amounts of the intelligence of a Maya model within CATIA. So we first went through an exercise of like mapping the complex nodes or history of parametric history. So, and this is what we would try to recreate in CATIA for a fabrication software, let's say. So, likewise, this is also another ongoing project, the interiors of cultural center. Again, the geometry types vary, like everything from subdivisions to NURBS to meshes.